Hi guys, in this video we are going to discuss the technique that will be using to solve the projectile motion problems. So this is what this meeting is about, technique to solve projectile motion problems. So we are going to discuss a problem that has came in the October 2022 exam in the international A-level paper. The question is that a ball throws a ball at 9.70 meter per second at an angle of 49 degrees. And we have to find out the time that the ball will take to reach the wall. So let's apply the technique. The step 1. The step 1 would be to choose the origin. The point from where the ball is thrown would be called the origin. The horizontal will be taken as the x-axis and the vertical will be taken as the y-axis. Now after that we are going to do the step 2. The step 2 is to find out all the known variables along the x and the y axis, and we shall write it in the table. Now here, as we know that whenever a projectile is moving, its acceleration is always vertically downward and its value is g. So this means that the x component of this acceleration is 0 and the y component of this acceleration is minus 9.8. We shall also resolve the initial velocity 9.70 along the x and the y axis. So the x component of the initial velocity is going to be equal to 9.7 cos of 49 degrees, which we have written here. This is ux, 9.7 cos 49. Similarly, we shall find out the y component of the initial velocity, which is 9.7 sine 49 degrees. This is what we have written here, 9.7 sine 49. Now, after finding these two, now we shall search for the third known variable. Now we know when the ball has reached the wall at this particular point, the x component of the displacement, as you can see here, is 5 meter. This shows that the delta x is going to be 5 meter. Now you can see that on the x-axis we have obtained three variables, right? We have got three variables on the x-axis. So that means we can apply the equation of motion. The we shall use the second equation of motion, which is delta x equals to uxt plus half axp square. We shall plug in all the values here and the time we will get is 0.8 seconds. Very good. We have solved the first part of the problem. The time is 0.8 seconds. Now the good thing is that because the time is same on both the axes, so as we have obtained it from the for the x-axis, its value will be same on the y-axis. So now we can do the second part of the problem. The second part of the problem is that we have to find out whether the ball will bend over the wall or not. So for that, we shall obtain the y component of the displacement of the ball. So for that, we have got everything on the y-axis. So we just need to find out delta y. So for that, we are going to again use the second equation of motion, which is delta y is equals to uyt plus half at square. We shall plug in all the values and we are going to get delta y as 2.73 meters. So this is the y component of the displacement. So you see, by applying the technique, we have got the y displacement also. So you see that just if we have formed this table, we will be able to find out which equation we have to apply, and using the right equation will give us the right answer. Now, as the vertical displacement of the ball is just 2.73 meters, which is smaller than the height of the wall, that's why the ball will not go above the wall. So this is going to be the final conclusion for this problem. So in this way, we are going to solve this problem. Thank you.